So it was clear to us that the force that was perpendicular to the axis or that was lying in the plane of rotation and the r that was the shortest distance, they were actually responsible for rotation. Fine. So now if I have got my r as well as f in the same plane, correct? They lie in the same plane. Now I ask you to look at it from above. From above. Okay. So they lie in the same plane. So I ask you to paste it on this board, which is also a plane. Do we get that? Both those components, the perpendicular of the shortest distance from the axis, that r, and the f perpendicular component of the force, they lie in the same plane. So I'll draw it like this, so you understand. Let me transform it. So something that was like this, and maybe the door was like that. Okay, and I'm not doing some carvings on the door. So and the force was like that. So I have resolved everything. I get that shortest distance and I get that f perpendicular, and I somehow shift it like this. So this part I bring here and this part is like this. So how does it look? This axis looks as a point, correct? And this looks like this, a line. It has become a line. Looking from here, it becomes a line. And the component of the force that is in the plane, that looks something like this in any direction. Okay, and this becomes the axis. The axis is kind of extending out of the board and into the board. Hope you understand. So this thing you are actually observing from here. With your hair like this. I don't know what it is. Oh, ये hair है आपका. Oh. Beyond that, I don't know drawing. Okay, so okay, fine. So you understand. यहाँ we are looking from above, and this looks like this. Okay. Now try to see. This is f perpendicular, and this is your CP vector. No, CP and f perpendicular, they were lying in the plane. So that's why I have drawn it like that. But later what happens, when you talk about that f and r, you do not distinguish it like that. You actually start calling your r the CP itself. Now you understand why we were led into believing that my r is that. That's a technical fault that we are committing. But this is the reason why we are taking r as our CP, and that keeps on shifting. You understand? Do you understand? It is due to that we had taken it as a shifting one, but at the background you should understand that your r is actually that vector and it has been resolved, and so many things have been done as I did in the last video. Okay? So let us try to think. So this f you actually start calling f, but this is not the original f. Hold that in mind. It is only that f which is causing rotation, and this CP we start calling r. It's not r. In the strictest sense, if someone asks you, is the r of r cross f the position vector for a fixed axis? That is no. Maybe. It's no. Maybe, but only for one case. Then the whole thing will disintegrate. Okay. Only for one case. Okay. So the general answer is no. Now I know that my torque is R cross F, which is RF sine theta, and in this case it will be pointing upwards, because this F has to shift here. The shifted vector I draw like this. F has to shift here. Before you initiate any dot or cross product, the vectors have to be made co-initial. How do you make them co-initial? Because we are dealing with free vectors which can be shifted parallel to themselves to without changing their identity. That means their length has to remain the same, they have to be parallel to themselves, their identity remains the same, so they still remain an A vector, and here they still remain the F vector. And I could have also shifted this here, no issues. R parallel to itself, so no issues. Okay. So F, R cross F goes like that, and no, R cross F comes out. No, comes out. You know this notation? You know this? This tells you pointing out. It's an arrow kind of notation. If it was a cross, it is going in. Why? Have you ever fired an arrow from a bow? Some professional arrow, not some arrow. It has got some stabilizing fins in the end, which are like this. One fin like this, another. Even at the end of darts, darts you'll find that. And now we have changed those darts, and we are having plastic darts, right? So even in the plastic darts you'll find that stabilizers, and if you have a dart whose stabilizer is broken, you'll find how it behaves. Fine. So looking from the back, it looks like a plus or a cross. So that is going in. That means you're looking at the arrow from the back, and arrow has no reverse gear, so it flies ahead. So that means you are looking at an arrow that is going into that, and if it is coming towards you, you are only able to see the tip, which is not true in the strictest of the sense. There will be either this also that you will see, but forget it.
So student, R cross F, so I didn't understand why have you taken RSCP?
RSCP because
R cross R to position vector था ना, point of interest
that you
पे
just mentioned.
origin से जो point of interest था वो R था, और इसमें आपने R बोली है जो perpendicular वो था CP था.
perhaps you missed what I said. I said this is actually CP, but we start calling it R, realizing that it is CP. Many places you will actually find this, but here you have to understand that you are taking CP and calling it R, and here you are taking the F perpendicular and calling it F. That's why I went on to that whole explanation for that only. That if you call it R cross F, you take the shortest distance, but it is due to that reason that you do it. But we do not keep on calling CP, right? We start calling it R. That is actually a source of confusion for people. Many a times, after you have deeply read it, then suddenly you will get confused. Why is R shifting? Why is my origin shifting? Am I taking a shifting origin? What kind of this thing is that where I take a shifting origin? No, we are not shifting the origin. Okay, so it is R F sine theta, and the vector is pointing outward. So this is my torque vector. This, correct? N cap is a normal vector, unit vector, normal unit vector. Cap is unit, right? This is called cap or roof. Fine. So this is RF sine theta. Now let us try to understand. this angle is theta, correct? And these two are parallel, so this is also theta, correct? Now if this is 90 degree, then if this is r cos theta, no, and this is r sin theta. Hope you know that resolving of the vectors. So this is your r sin theta. So I can call it f into r sin theta into n cap. N cap is what? Unit normal vector. N stands for normal, cap stands for unit. So f into r sin theta into n cap, and r sin theta is what? It is the perpendicular distance of the axis from the line of action of the force. Do you get that? So I can very well write it as f into r perpendicular n cap. Correct? So actually it is this arm that magnifies or diminishes your effort. You understand? How much away you are from the axis. And when will you be the farthest? When will you be the farthest? This. When will this be the longest? When I'm at 90 degree. What happens if I'm at 120? If I'm at 90 degree, this is my distance. If I become, say something like this, what happens? This becomes my distance. Don't think that it's going away, so it'll keep on going away. Why? Because my perpendicular distance will now become this, and you'll never be able to find a perpendicular distance here. So you understand? No. Perpendicular distance from here. What happens? If it is this, then the perpendicular distance is this whole r. If I make it like that, then what happens? We feel as if so this perpendicular distance actually slides like this, comes here, and then travels here. You know, this becomes the perpendicular distance of the line of action of force. That means if my force was like that, then my r perpendicular would have become this, and it will be shorter than this. No, you don't understand? Doubts? Ask it if you have doubts. See, I am like this, the perpendicular distance is like this. This is smaller than this. It is r sin theta. Sin theta is at the most what? 1. So the maximum distance that r perpendicular will be r, and that is when my line of action is perpendicular to it. That's why try opening a door by sort of like making an angle like this, you'll find the effort goes up. Or like this, your effort goes up. So you are the best when you come and perpendicular to it, you just push or pull. Why? Because with the same force, since your r perpendicular starts going up, it is f into r perpendicular that is actually giving you the torque, the advantage of rotation. Correct? No? So So magnitude of torque is F into R perpendicular. There's another way of looking at it. There's another way of looking at it. Do I erase this? Hmm? Now, try to think. This angle is theta. So, this angle is theta. Now, this can be resolved into two components. One of them is, this is F cos theta. If this is 90 degree, is it not? This is F cos theta. F cos theta. And this is the one which is perpendicular to it is, this is F sin theta. This is F sin theta. This is how you resolve it. So that they have to be perpendicular to each other. The two, and why do you do that? Its origin lies in your kinematics, motion in a plane, which tells you that mutually perpendicular forces do not affect each other. Right? So the force in the x-axis causes an acceleration along the x-axis, and it never ever disturbs either the y or the z-axis. So that's why we do this. Otherwise, what will happen? You can resolve in any angle that you want, and at the end of the day, what will happen? That some portion of that is affecting this, and some portion of that is affecting that. The division of labor will be blurred. So we don't want that to happen actually. Okay. So F cos theta and F sin theta, and F cos theta, since it is parallel to the R vector, this is parallel to the R vector, so this will not be able to cause any rotation at all. Correct? This will not be able to cause any rotation at all, and it is only the, so tau is equal to only the F sin theta which causes the rotation. Okay, so I can also write it as R into F sin theta into n cap. And what is F sin theta? It is the perpendicular, it is the component which is perpendicular to the R, which is actually Cp. We have given it a name change midway. Don't forget it. Okay? So this is R into F perpendicular n cap. So tau can be, tau is equal to F R perpendicular, that is also F perpendicular R. I'm only talking about the magnitude. You'll have to still decide the direction of the torque, and the direction of the torque is a bit weird. The whole thing will be rotating like this, and the torque will be up. Okay? And many a times, matching it with the force, you will feel that the whole thing should be moving up while the torque is like that. But no, it does not happen that way. Because that is the direction of the acceleration, that is the direction of velocity, and we were actually forced to define velocity like that. For those of you who have you have done that part?
Yes, sir.
Angular velocity thing you have done?
Yeah.
Okay.